All right, let's get right into it. We're in this global race to power our world with green energy, right? But it turns out there's a huge fork in the road. And today, we're looking at this high-stakes battle between two totally different ways of storing that energy: batteries versus water.
You know, we all see these amazing wind farms and solar panels, and they are the future. But, and it's a big but, the sun doesn't always shine, and the wind doesn't always blow. This is what's called intermittency, and it's kind of the Achilles heel of renewable energy.
And that leads us to the billion-dollar question. If we want to go all in on green energy, we have to find a way to bottle up all that power when it's sunny and windy and then use it when it's not. We need a giant energy piggy bank. So what do we build it out of?
And this brings us to what we're calling the green energy dilemma, because the choice we make here isn't just about tech. It's a decision that's going to lock us in for decades, and it'll shape our whole economy and our environment.
And believe me, the pressure is on. The more renewables we build, the more desperate we become for huge, reliable storage. And right now, there are two main contenders stepping into the ring.
So first up, we have the modern champ, batteries. You've probably heard of them as battery energy storage systems, or BESS. And you know, on the surface, they seem like the perfect 21st century solution. The big thing with batteries is they're fast. You can build them pretty much anywhere, and they get going quickly, which makes them feel like this great plug-and-play solution. But if you start looking past year one and you think long-term, some pretty serious cracks start to show.
So let's just break down these challenges. First off, lifespan. A typical battery system is only good for about 8 to 15 years. That means you have to replace it a lot. Then you've got the raw materials. Lithium, cobalt, their prices are all over the place. And there's huge competition for those minerals from electric cars and everything else. And on top of all that, you have the very real environmental problems that come from mining this stuff. And this isn't some far-off problem. The pressure on these supply chains is already intense, and it's just set to explode as the whole world electrifies. That is a massive risk if your entire long-term plan depends on these materials. Okay, so let's switch gears and talk about the other contender. It's a technology that's actually been around for more than 100 years, but people are starting to see it in a whole new light. Let's talk about pumped storage hydropower. You can basically think of it as nature's original battery. The idea here is actually super simple. It's kind of brilliant. When there's extra cheap power on the grid, like on a really sunny, windy day, you use it to pump water from a low reservoir up to a higher one. Then later, when everyone gets home from work and needs power, you just let the water flow back down through a turbine, and boom, you're generating electricity. It's a giant, rechargeable water battery. And that's really it. No complex chemistry, no rare minerals from halfway across the world. Just water, a couple of reservoirs, and the most reliable force on Earth, gravity. It's a beautifully simple fix for a really complex problem. You see, PSH is playing a totally different game. We're talking about storing massive amounts of energy. And the lifespan? We're talking 80 years or more, with almost no drop-off in performance. It's proven, it's super reliable, and it runs on water, not on some shaky global supply chain. I mean, just look at them side by side for a second. This is where it gets so clear. On one side, you've got an asset that lasts maybe 15 years max, and it's totally dependent on a wild mineral market. And on the other, you have a piece of infrastructure that lasts over 80 years and literally runs on water. This one comparison changes the entire financial picture. And that brings us right to the money, doesn't it? Because when you're investing in something for the future of the grid, you can't just look at the day one price tag. You have to think about the total cost and the value over the entire life of the thing.
Look, a PSH plant, yeah, it's a big investment up front, but it's pretty much a one-time cost. A battery project might seem cheaper to start, but you have to buy the whole thing all over again every 10 or 15 years. And every time you do that, you're gambling on the future price of minerals and batteries. Meanwhile, that hydro plant, it just keeps chugging along for decades.
But hold on, the financial story doesn't even stop there. We've got to talk about carbon credits. Just think of them as a financial reward for being clean. The less carbon you pump out, the more of these valuable credits you can earn. And the difference between our two contenders here is, well, it's huge. Because of its super long life and its cleaner process, a PSH project can generate about 75% more carbon credits over its lifetime than a battery system doing the same job. So why is that? How does that happen? Well, it's because when you look at the whole picture, the mining, the manufacturing, all those replacements for the batteries, the carbon intensity,
basically the pollution for every bit of energy stored, is 30% lower for pumped hydro.
Okay, so what does this actually mean in dollars and cents? It means a typical PSH project could rake in over $85 million in extra revenue just from carbon credits compared to a battery project. That's a massive financial win that comes simply from being the cleaner, longer-lasting choice.
So when you put all these pieces together, the source material really makes a case for a totally different way of thinking about these investments. This isn't just about patching a hole in today's grid. It's about building a truly resilient and sustainable grid for our kids and grandkids. Let's just sum it up from an investor's angle. With batteries, you're signing up for economic volatility. You're tied to replacement cycles and mineral prices. With hydro, you get predictable, long-term returns. When you look at ESG goals, batteries have higher emissions and serious supply chain issues. Hydro is cleaner and generates more of those valuable carbon credits. At the end of the day, one is a short-term tech gadget and the other is a piece of long-term, foundational infrastructure. Now, the big takeaway here isn't that batteries are useless. Not at all. They're actually really important, especially for quick, short-term grid needs. But the core argument from our source is that for the massive, long-haul storage our future grid absolutely depends on, we need to be investing in foundational assets. We need to build things that are made to last for generations.
And that leaves us with one final, big question to think about. As we race to build this cleaner world, are we just looking for the quick fix that gets us through the next 10 years? Or are we thinking bigger and building the kind of enduring infrastructure that will power us for the next 100? The choice between the sprint and the marathon is going to define the future of energy for all of us.